stop that. Okay. So to roll this up a little bit, there are problems we have in NAV with indexes because we have indexes in a certain way. We have cursors, we have keys. There will be always something stupid in NAV. You will always have queries that consume a lot of I/O, taking ages to execute. Troubleshooting this within NAV is hell. You all know the NAV code. It's a gazillion of lines to troubleshoot, and it's just a hell of work. With SQL features, it is easily possible first to find out about problems, to really having hard facts. It's not just what you usually get from the user, "Oh, everything is shit, nothing's working." No, you can put it down to the fact, to the number. You can really say that's that many reads, that many CPU milliseconds and stuff. So you can identify problems. You can do a very, very detailed investigation, starting with the script to quantify them. Then you have execution plans, query statistics, and everything. So you get the full picture of what's going wrong. And in most cases, I dare say it's 90% of all query problems, it's missing indexes. It's because you have insufficient index structure. And the easiest way to fix this is to do it on the SQL Server side. You don't have to fiddle with NAV with all the consequences. You can do it on during business hours. You get instant feedback from the system, from the hard facts, and also from the users, because suddenly it's not, "Oh, everything's shit." Now, hey, it's quick, it's fast and stuff. So, imagine if you do this in NAV. So after business hours in the evening, I have to change item ledger entry, bring this to life. It doesn't work. Oh, pity. If this doesn't work, well, there's a drop index command, and then it's gone. In NAV, pity, I have to remove this index tomorrow evening. And so on. Nah, that's okay. So, and this is really what I want to encourage you. Do this in SQL Server to have a quick benefit. And afterwards, you still can make your mind up if you want to have this solution in some kind as a key in NAV, if it's compatible. Because that's something you can do afterwards. First thing is solve the problem. Happy customer. Fast system. And when you know what is the goal, what is the target to reach, then you can afterwards think and do it in NAV. Or just leave it in SQL. But actually, that's a philosophical question. One thing I want to also mention here is the sustained engineering once provided also a script which is looking into the query caches. I have the link here to the blog. So if you don't do it with a profiler, this is instantly looking into the cache and having also a similar idea to display the number of reads, execution times, and so on. So that's also something from Microsoft you can use. So it means the worst problem is wrong or missing indexes, which we can fix now. No problem. So what helped us in this first part was this index usage statistics. Because actually we have another problem. And this is because NAV is totally over-indexed, so to speak. That means there are so many indexes, keys and indexes, that are just causing super load on the system and slowing down write performance dramatically. The reason is simple, because we need to have a key for every sorting order. So what we often do is we just copy-paste a key and change the last two fields. Now just look into the sales line table and you find 5 keys, all starting with document type and something else. So, and usually every key corresponds into an index. And that's why we have many, many, many indexes, especially partners that having lots of add-on solutions, and every add-on is adding 5 and 10 indexes to the important tables. But SQL Server is actually a smart thing. It will pick out the best index available and ignore the other ones. So what we need to do is to find out which indexes are used indeed. And when we know which indexes are used, we exactly know on the other hand which indexes are unused. This is what we can do with this statistic, this index usage statistic. The only problem is here, quite a practical thing is, in NAV, not every process is run every day. Yeah, so it's not going on everything. So the problem with these statistics is they are always reset if the service is restarted. For example, if you install a service pack or an update, service is restarted, all statistics are 0. And if you do an index unused investigation, system will tell you all indexes are unused, drop them. Hooray. I hope you agree with me that this will probably raise a tiny problem. No. So what we need to have is a reliable statistic about the actual index usage. And also this is fairly simple. So I recommend to do is I just create a little table here. I call it index usage for a certain reason, which will give me an error because this table already exists, doesn't it? Yeah, it does. Yeah. And now what you can do is you can create, for example, an SQL Server agent job, which periodically just saves the system statistic. So I just have a job running every 2 weeks, every month, every week, whatever frequency you think is suitable, and then I just copy the system statistic. So if the service is restarted and the stats is nulled, is reset, who cares? Because I have my record of this. And then when you say that you have now investigated for a reliable period, yeah, that's the important thing. So to monitor really everything that is important, like end of month procedures, quarterly reports, physical inventory, maybe end of year processing and something. When you say, okay, now we have seen everything that is important, then you just can run an investigation. And here this query is querying the maximum usage. This is already filtering. So here I have some indexes that have never been used, but often updated. So they were causing load, but given no benefit. Now, in the period I was recording, which is just a couple of hours since I started this box. Because the risk is if you get rid of such an index and then suddenly there is a report which needs this specific index, well, then maybe this report will take an hour instead of a minute or something. Then the next important step is here. If you browse this in the internet, you will find lots of queries and examples that propose you some drop index statements and how you can get rid of these indexes from a SQL Server perspective. Never, 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 did I say never? Never, really never, never drop an index on SQL Server side if it's an Navision index. You can do this with your own stuff, never drop an NAV index. Perception and reality, this is important. So if you have an index defined in NAV and it does not exist anymore, then sooner or later you really will hit the wall. So the shit will hit the fan and you will stand in front of this fan. Yeah, so no, if Navision indexes are dropped, then Navision has to drop them. And in this case, for example, document dimension 357. Technically, what you have to do is that in this case we know that's $1. This is $0. This is $1, and this is why we have this property maintain SQL index. So I have to remove this, and then Navision will drop this index, and then the Navision expectation matches the SQL Server reality. So this is important that both worlds are in sync. Never do this with the enabled flag. Enabled is completely disabling the key, not just the index. So you cannot use this key specifying in a set current key command or table view property or whatsoever. So then it's totally out of NAV world. And we're not talking about NAV world, we're talking about SQL thingies. So this is the flag to fiddle with. Yeah. In this case, that was actually quite easy to pick out the index $1 It will be a little bit trickier if you have table and then tells you $35, because it's not necessarily really the index number 35. If you count them from the top, there can be gaps in it and everything. So that's tricky business. Again, there are tools that can do that easily with a few mouse clicks to relate this to the right division key and stuff. So that means, on the one hand, we will add indexes to improve queries, and on the other hand, we get rid of indexes we obviously don't need. So that means that's just a matter of time and effort you want to spend for this troubleshooting, but sooner or later, the system only has the indexes it really needs. So you can find the right balance between read and write performance. Improving the read queries with maybe added indexes, and improving the write performance by getting rid of unused indexes. Yeah, so far, so good. If we have indexes, regardless how they are created, where they are coming from, to round up this whole index thingy, indexes require maintenance. That's really crucial. Maintenance will not make your system faster. It's like changing oil with your car. Your car will not go faster if you change periodically the oil, but if you never do it, sooner or later your car will break down. And this is exactly with index maintenance the same. Indexes fragment. That's a natural thing because you insert data, you delete data, you change data, so you have actually gaps, let's say, in these index trees. And the more fragmented an index is, the slower it performs. So it is absolutely necessary to periodically maintain these indexes, get rid of unused space, keep them small, and so on. In standard SQL Server, we have actually a maintenance plan feature. And this maintenance plan provides actually two tasks for this job, for defragmenting indexes. That's the reorganize and the rebuild. The difference is briefly, a reorganize just takes care about the most detailed level of an index, the leaf node level, but it will not give an optimal result. As the reorganize is working on a very small granularity that's causing almost no blocking issues, so it's running very smooth while parallel transactions work. But it will record a hell of information into the transaction log. The transaction log will increase in size dramatically. If a reorganize runs throughout the whole database, it could happen that the transaction log has the same size as the database. So that's the reorganize, and the rebuild, that's the big brother. It's taking care about the full index, giving the best result from a defragmentation perspective. But actually it's causing a hell of blocking issues because it's completely locking the index. So it's not possible to work with this at all, except if my mouse is responding.